Hello Year 10, welcome to our first topic of the year, which is algebra, equations and linear relationships. Today we're going to do a quick review of algebra and we want to go through a few of the terms that you need to be familiar with. So at the top of the page we have this very massive big thing here and we're going to be talking about the different features. So first of all, it is an equation. The reason it's an equation is because it has an equals sign in it, and we have a left-hand side and a right-hand side and the equal sign in between. In that equation, we can also have what are called expressions. So if we just took the left-hand side of the equal sign, the 3xy plus 2x minus 7y, that is an expression, because it has terms in it, it has letters in it, it has numbers in it, but it does not have an equal sign, so it is not an equation. Likewise, I could do the same thing with the right-hand side. That would be another expression. We also have what are called terms. Terms are the individual things that are separated by plus and minus signs. So 3xy is a term. 2x is a term, minus 7y is a term, 12x is a term, minus 5y is a term, and 10 is a term. All right, next word we need to know is the word coefficient. The coefficient is the number in front of the letter. So if I take this first term, which is 3xy, the coefficient of the xy is the number 3. So you could get a question that says, what is the coefficient of the y term? So you'd find the term that only has a y in it, which would be this one, or this one. There's actually two of them in this question. And the coefficient would be either a minus 7 or the minus 5. There is also a special one that is called a constant term. A constant term is a term that has no letters in it, so 10 would be an example of a constant term. Pronumerals are the letters that we use in our expressions and equations. Our equation has two pronumerals in it. It has an x and y's, and they are often used in place of a number. Adding and subtracting. If you are adding and subtracting in algebra, you can only add or subtract like terms, which are ones that have the same letters. You don't have to worry about the order of the letters, so an xy is the same as a yx. As long as it has exactly the same letters, then you can add or subtract the coefficients. Multiplying and dividing does not have to have like terms. You can multiply and divide anything. There's a box here with some hints in it. If you are multiplying, you multiply all of the coefficients, which is the numbers in front. You do that first, and then you collect up all the pronumerals. When dividing, you can write your question as a fraction or divide the numbers, and the letters will cancel out. So if you have an x on the top and an x on the bottom, they will cancel out. We'll do all of these things in our examples in a minute. Expanding means getting rid of the brackets. So there's a little example here. We have 2 bracket a plus 3. To expand it out, the 2 has to multiply by each thing inside the bracket. So 2 times a makes the 2a. Then we want to plus 2 times 3, which is the 6. And the last word we need is factorizing. Factorizing is the reverse of expanding. It means we have the expanded version here and we want to factorize it back up by taking a common factor, which would be 2 out the front, and putting the leftovers in the bracket afterwards. Okay, so now that we've been through all of the terminology, let's quickly go through some examples. So question 1, we want to simplify. Now looking at the symbols that we have, this first one has a plus sign. So as long as I have the same letters, which I do, they're both Y's, then all I need to do is add the numbers in front. 7 plus 8 is 15, and then Y would be the letter. Y's do not collect up when adding, they stay the same. In B, we have a number of different terms here, but again, because we're adding and subtracting, I need the ones that have the same letters. So 3mn and 8nm, even though they're in a different order, they are like terms. 3 plus 8, you always take the symbol in front. 3 plus 8 makes 11mn. The plus 2n and the minus 5m are not like terms, so they cannot be collected together. We're just going to write those down at the end. Okay, moving on to the next one. We have 7y squared, but a y squared is different to a y, and so they're not like terms. And x squared is different, so the only ones that are the same are the 3y and the 6y. So let's add those together. 3 plus 6 makes 9y. Then we have the plus 7y squared minus 3x squared. So the ones that aren't like terms, again, just sitting there at the end. On to D, minus 2a squared b. So an a squared b is different to an ab squared, so the squared is on a different letter. But this one down the end is also an a squared b, just written in a different order. So they're our like terms. We have minus 2 plus 1, there'd be a sneaky 1 in there. So minus 2 plus 1 makes negative 1 or negative a squared b. It doesn't matter the order of the letters, usually we go alphabetical order though. The next two terms are not like terms, so we're just going to put those down at the end. Okay, moving on to question 2, we're still simplifying, but now you can see in here that we are multiplying and dividing. These should be divide symbols down here. Okay, so when we are multiplying, the rules are that we multiply the numbers. 2 times 5 is 10, and any letters are going to collect up, so AM. It works for 3 terms as well. We multiply all the numbers at the front, so 3 times 4 makes 12, and then we collect up all the letters, usually in alphabetical order, so E and then MN would be alphabetical order. Question C, fractions mean that we are dividing. So we would want to go 8 divided by 14, but that's not going to go nicely. We certainly don't want to go to decimals, but we want to simplify the numbers down as much as we can. So we could divide the 8 and the 14 by 2, which would give a 4 on the top and a 7 on the bottom. With the letters, we can cancel the B from the top and the bottom, because remember, dividing, the letters cancel out, and that will just leave an A on the top and a C on the bottom. Question D is very similar, so let's look at the numbers at the front first. 32 divided by 16 does go nicely, it goes exactly twice. Then we're going to look at each letter that has the same base. So first of all, a to the power of 7 and a to the power of 3. Now when you're dividing, we're either cancelling the letters off, or the other way to think of it is that you subtract the powers. So 7 take away 3 would be 4. It would be a to the power of 4. Then looking at the b's, we have one b on the top and one b on the bottom, so they're going to cancel out completely. And the c's, we have 4 on the top and 1 on the bottom, so again let's subtract those powers. 4 take away 1 is 3, so it's c to the power of 3. Question E and F are also dividing, but this time they actually have divide signs, not fractions. But that doesn't mean that you might not want to write them as fractions so that we can avoid doing decimals or other horrible things with our solutions. So 7 divided by 14, straight away we can realise that's not going to go nicely. So best idea is to turn that into a fraction, 7mn over 14m squared n, so that we can simplify and leave our answer in fraction form. So 7 and 14 we can divide by 7 on the top and bottom and get a 1 on the top and a 2 on the bottom. The n on the top and the n on the bottom will cancel out completely. The m's, I have 1 on the top and 2 on the bottom, so I can cancel 1 from the top, 1 from the bottom. So I'll cross off the squared so that I still have 1 left on the bottom. So the 1m left on the bottom, I'll put it there, so it's 1 over 2m. F, I'll do the same thing. Because 7 divided by 21 doesn't go nicely, I'm going to write this as a fraction first. So minus 7 PQR over 21Q squared. 7 divides by 21, or 21 divides by 7 3 times. So we can simplify those numbers down to be a negative 1 on the top and a 3 on the bottom. Then looking at the letters, on the top and the bottom we have these Q's here, but we have 1 on the top and 2 on the bottom, so I'm going to cancel 1 from the top with a 1 on the bottom, leaving 1 Q still there. So I'm crossing off the power so I can still see the Q on the bottom. Writing down what is left, I only have a Q left on the bottom, so 3Q on the bottom. I have a P and an R on the top. Now normally we don't want a minus 1 in front of a P and an R, so we just get rid of that 1 there and just say minus PR over 3Q, just to be a little bit tidier, a little bit more simplified. Question 3. Expanding the brackets means we're multiplying out. 3 times A is 3A. Plus, we have a plus sign in between here, then we're going to multiply the 3 with the 5, which is 15, and that's it. That's how you expand. You have to be a little bit more careful when there's a minus sign at the front. So let's try this next one. Minus 3a times 2m. Minus 3 times 2 is minus 6am. Now we're going to do minus 3a times minus 5n. The minus times the minus will make a plus. 3 times 5 is 15. A and N are the letters that are collecting up there. Okay, so that's basic expanding that you've been doing for a few years. We're expanding again in question 4, but these ones require 2 brackets to be expanded, and that will probably lead to some terms being able to be collected as well. So let's start expanding. 2 times A is 2A. Then plus 2 times 7 is 14. Now we're starting again with it. We have this plus sign here, and then we start just with the 3 and times it into the second bracket. 3 times A is 3A. 3 times 2 is a positive 6. Okay, then you can see that we have some like terms. The 2A and the 3A add together to make 5A. And 14 plus 6 makes a positive 20. Let's do another one. Let's times the 3g through the bracket. 3g times g is 3g squared. Plus 3g times 5 is 15g. And then the minus 5 is going to times into both of these, the next bracket. Minus 5 times 2 is minus 10g. Minus 5 times minus 3 makes a plus 15. Looking for like terms, a g squared is different to a g, so the 2 middle terms can go together. That will leave 3g squared as it is. 15 minus 10 makes 5g, and then plus 15 on the end. Okay, Question 5 is factorising, which is reversing the process where we want to put it back into brackets. So the first thing you do is you look at the terms that you've been given. And remember, the terms are separated by the plus and the minus signs. So we have got two terms here, the 9m and the minus 12. So I look at those numbers first and I say, what is the biggest number I can divide 9 and 12 by? And the answer is 3. So 3 is going to come out the front. Now, letters can be factors as well, but the letters have to be in both of them for them to be a factor. So there's no common letter factor for this one. So I'm going to open my bracket, and then I need to divide each of these starting terms by 3 and put the leftovers in the bracket. So 9 divided by 3 is 3m. We need the 3 and we need the m. Then I have the minus sign and I go 12 divided by 3 is 4. Close the bracket. And you can always in your head try to times that back out again and check to make sure it goes back to the original question. Looking at B, we have 25 and 15, and the highest number factor of that would be 5. Looking at the letters, we have A to the 8 and A to the 6. So it's a lot of A's in there. We can take out a common factor of A to the 6, but there'd be 2 extras in this first term here. So when we divide, we'll do 25 divided by 5 is 5. 6 of the A's have come out the front, which means I still need 2 of them inside. Moving on to the 15, 15 divided by 5 is 3. All 6 of those A's have come out the front, so that's it. We close the bracket. Question C. There's 2 ways you could do this question. The question is kind of hinting that it wants you to take this minus sign out as a factor because it's out the front here. In my mind, the minus only has to be a factor if it's in both of them, but we'll practice taking the minus sign out because I think that's an important skill that we need to do here. So let's bring out a minus 4 as our factor. And if I take that from the first term, that's only going to leave the D left. When we move to the 28, 28 divided by minus 4 will make a minus 7. Because again, think in reverse. If you were timesing those together, minus 4 times minus 7, the 2 minuses will make a plus 28. Question D. There are no numbers, big numbers out the front here. So the only factor we can have is the letter E. If I take E out the front, this first term has 2 of them. So if one's out the front, the second one will be inside. Then we have minus sign. The E has come out the front. If the whole thing, there's nothing left of that term, what's left is a 1. Close the bracket. Okay, on to the next page to find some of the harder types of questions that you might see in the exercise that you're going to do. So we'll put a little star next to these ones because these last 2 are the more challenging ones. It says, find an expression in simplest form for the perimeter and the area of the following shape. Now, perimeter is just all of the outside lengths added together. So we have a few missing ones, so let's work out what they are first. If we have got a 2 and an x minus 1 horizontally there, then we would want to add those together to get that whole side across there. So x minus 1 plus 2 would be x x minus 1 plus 2 would be plus 1. X plus 1 for that whole side. Now, let's go vertically and say this whole side here, which is x, and this little side here is 1, and I'm trying to find this missing side. Now, the 2 shorter ones should add together to give the x. So if I want to find this one here, I'm going to have to start with x, subtract off the 1 that's up here, so this side here would be x minus 1. Okay, so let's start with P for perimeter equals, and we're going to go around the shape and add them all up. I'm going to start at the top. I have x plus 1. Then going in a clockwise direction, my next side is an x. I'm going to plus x. Then I'm going to plus the 2, which is at the bottom. Then I'm going to plus the x minus 1. Then I'm going to plus another x minus 1. And then I'm going to plus the 1 from the end. Okay, collecting up all the like terms. We have x plus x plus x plus x. So altogether that's 4 x's. Then we have 1 plus 2, so that's 3. Minus 1, that's 2. Minus another 1 is 1. Plus 1 is back to 2 again. So 4x plus 2 for the perimeter. Okay, remember we need to find the area as well. So area of a composite shape, because that's what we call this, where we've got two shapes next to each other, we're going to have to cut this shape up. I'm going to cut it down there into 2 rectangles. So it's going to be the base times the height of the first rectangle plus the base times the height of the second rectangle. Now, let's take this little one up the top here as my first rectangle. Its base is x minus 1, not the x plus 1, because the x plus 1 goes way too far over here. X minus 1 is the base, and the height would be 1. So we're going to have 1 times x minus 1. 1 times anything is just x minus 1. Then we're going to go plus. Now we're going to do the base and the height of this long rectangle. The base is 2 and the height is x. 2 times x makes 2x. All right, that works. Now we have some like terms. X plus 2x makes 3x, and then minus 1 sitting on the end. Okay, so that wasn't too bad. One final question, which also gets a star. Question 7. Find an expression in simplest form for the perimeter P and the area of the shape shown in terms of pi. So it's going to be in terms of pi because we have circular parts in it. And in terms of pi means we don't want to go to decimal places. There is going to be pi in our answer. And also some x's because there's x on my side lengths here. So again, perimeter and area. Let's start with perimeter. Let's see if we can work out as many of the missing sides as we possibly can. So the perimeter of the shape, we have the 2x minus 3 and we have the x here. If that's x, then that side there must also be x. And this side here must also be x. So that's a sector there of our circle. And that means that this long side across the back here would have to be 2x plus x, which is 3x, minus 3. So I know the straight sides. I don't have the shorter side, the curvy side there, sorry, yet. So let's try and work out a formula. P for perimeter equals, if it's a quarter of a circle, then it's going to be a quarter of the circumference of a circle formula, which if I know the radius is 2 pi r. Then I'm going to add on all the other sides. So I'm going to go plus side, plus side, plus side. So they're all the sides that I'm going to add on. Okay, so let's sub into that formula. A quarter times 2 pi times my radius, which is x. Okay, my first side, I'm going to go across the top, will be 3x minus 3. My next side is going to be the x, and the final side is 2x minus 3. Okay, trying to tidy this up a little bit. This first term is probably the yuckiest one. A quarter of 2 is a half, and we times the pi and the x next to each other. Don't try and type in your calculator because then you're going to decimal places, which is not what we want. We want the pi to stay in our answer. So that's the first term. Then these other ones at the end here, we're going to collect like terms. We have 3x plus x, so 4x, plus another 2x makes 6x. Then minus 3 minus another 3 would make minus 6. All right, so that would be our expression for perimeter in terms of pi. Let's do area. Area equals. Okay, we would do the big outside rectangle, which would be base times height, and then I would subtract off my quarter circle that's been cut out of it. So a quarter of, if it's area now, is going to be pi r squared. So the base and the height of my rectangle, the big outside one, is going to be x times by 3x minus 3. So the height is the x, 3x minus 3, the base, I'm timesing those together. Then I'm going to subtract a quarter times pi times my radius of my sector, which is x, so x squared. Okay, I can expand that out. X times 3x makes 3x squared. X times minus 3 is minus 3x. And then unfortunately, I can't really tidy up that last term except to take the times sign out and just put it next to each other. So minus a quarter pi x squared. So that is an expression for the area. The only other thing that the answers in the book could possibly do would be to try to collect up like terms, which would be the x squareds here, for example. So they could write that as, let's take the 3 and the minus a quarter pi out of the x squared. So there's the x squared coming out of both of those terms, and then putting the minus 3x at the end. But in terms of what we would expect, I'd be happy with the that line there. Okay, so your turn now to do exercise 1A.